couple of gaps, picked up my header, I don't know why those gaps. But that's the type of data it used. Okay. What else do I have to cover? A couple of pictures from the I want to talk a little bit about transport lag, and I'm going to show you certain things that happen. This is a plot of yield monitoring and instantaneous flow measurements. And this is actually the standing corn. This is time, or you consider it distance traveled. And this is your grain flow sensor in pounds per second. And what this is just an indication of where the corn is. So at 10 seconds, essentially, combine goes into the corn. 15 seconds, I'm 5 seconds into the corn, I got still nothing going across my impact sensor. 20 seconds in, I've got nothing going across my impact sensor. About 22 seconds in, dink, the first kernel hits my impact sensor. And then it ramps up. And so I'm not at full flow until about 30 seconds later. So the transport lag for this combine is somewhere between 22 to 30 seconds. That's how long it takes for that corn to go from the header until it dink, hits your impact sensor at the clean grain auger or elevator. And then you get all this kind of variation in the field. Then when you exit the field, so if I'm calculating bushels per acre, in this part of my field right here, and again I said this is time, but it could be distance, what's my yield? 0. You look through the equation. I get 0 pounds per second, thus I have 0 yield. So part of my field, even though I'm into it, I'm recording as 0 yield. And then coming out of here, and a lot of times this will happen, I'm out of the corn over here, but it's still indicating that I had yield. So it's pushing that yield way out here. And as a matter of fact, a lot of times people will actually stop when they come out of their header, if they got to turn around or something, while the grain's coming across their impact sensor. So you have a huge pound, you have a lot of pounds per second going across your impact sensor, but my distance is essentially 0, or my acres are 0. And my yield goes through the roof, yield in terms of bushels per acre, because I'm not traveling any far. And that's called ramp down. So we have some sort of problem. Now this is most people recognize that happens. We have this transport lag. And most of the time, that's accounted for. You actually can program it in. Or as you go into the corn, they say, hit this button on this little display. And then it kind of monitors how far you're traveling and how long it takes for that corn to start hitting your impact sensor. And then it will actually do it for you. It will account for that transport lag, and it will take all this data and just shift it back here. It says, okay, that yield that you're measuring, that's not for that position. That's for that position that was 22 seconds ago or 25 seconds ago. So that's how transport lag compensation is done. Because they recognize that there is a lag and they compensate for it. Now some are default. Some you don't touch anything and it's embedded into the combine because the company kind of knows what you put in your combine's model and it gives you a default transport lag. But that transport lag is highly dependent on your bushels per acre. Now, why is that true? Because if I have a very thin crop, and I've done studies with this before with transport lag, it takes a long time for my combine to fill up, as they say. As I'm moving through my field, I'm getting a lot of stuff, it's filling up, and then all of a sudden it's going across the yield, and it might be 30 or 40 seconds. And we've done studies with combines doing like 2 rows, 4 rows, 6 rows, 8 rows, changing the mass flow rate in the combine. But if I come into a yield that's got a lot of grain in it, that combine fills up quickly, and the time for this to start is small. So it is dependent on the density of your crop.
Now, to eliminate that, could you just park your combine at row 1, and when that sensor turns on, then you hit the gas? And then start recording GPS?
Well, you'd have to get into the crop to get the crop up into the...
Like, what I mean, like, if you park your combine right at row 1 and it started...
You start your run to, but you're not bringing any crop in.
Well, you're not moving.
Then you're not bringing any crop in.
Well, yeah. I mean, you would go to row 1 and
Yep.
stop.
Okay, I'm
And
here.
then corn, okay, it's taking a while for it to process.
Well, you're not in the corn yet. Are you at the beginning of row 1? Where am I? Here's where the corn starts, and I'm the
You
head.
go to right where your combine is starting to pick up corn, and then you stop.
Okay, so you're in here, and then you stop.
And then when that sensor goes off, then you start recording GPS.
But you need to continue to fill it up.
Yeah.
I think, you can go in a little bit, and it will still, it will start to fill up. But then when you start moving again, it's going to take 20 seconds for that new stuff to go by there. So you just go stop and go stop and go. It's a good thought, though. Good thought. But it's still going to take that time to go through that combine machinery. Okay, so when we start talking about transport lags, this is the concept in here. And I'm going to show you, and as a matter of fact, there are several pictures. So I think everybody sees what we're doing with the, and we're not going to do any compensation for our yield. Okay? Now, I want to show you something in the back. When I see a map, and this is in the back of your text. This is a great, I'm not going to pick on anybody here. Okay. And I'm going to look at this right here. This is combine yield data. And when I look at this combine yield data, and I see these little pokes here, that tells me that that transport lag compensation for that combine is not programmed properly. Because I know he's going this way. And it's dragging that, on this point, he's dragging that corn out of his field. And then he's coming back this way, and he's saying that there's no yield right there next to it because that yield's being compensated here. And I would bet if he came in on the yellow part, he's going to go out on a red part up there. Because those corn, this is my field actually doesn't go like this. It goes straight across. Yellow means really low yield. Red means high yield. Okay. It's straight across here, but by having these little jags indicates to me that that transport lag in that combine is not set properly. And this whole thing this whole row needs to be adjusted that way, and this whole row depending on which way it's going, needs to be adjusted down the other way. So you can almost look at a yield map and see that and figure out what's going on with that yield. Now this is one of those raster maps too, that's just a little bit scary because it's a cell map as opposed to a triple